Hi guys, and welcome to Unit 6.6 notes from my kitchen table. I hope everyone is doing really well. I just want to remind you, as you're taking your notes, feel free to pause me, stop me, slow me down, fast forward me, whatever you need to do to be able to get through the notes. All right, so let's start with we're going to start with a question of the day here in a minute, but I do want you to remember this is the unit of units. Remember that when we're talking about gas laws, it's really important that we recognize units. Remember, temperature always has to be in Kelvin, so that means you need to change any Celsius to Kelvin by adding 273 to them. Volume is usually going to be milliliters or liters. Sometimes you might see centimeter cubed or decimeter cubed, but for the most part, it's going to be milliliters and liters. And unit of pressure will always be mmHg, atmospheres, or kilopascals. All right, so here's our question of the day. This is a review of the combined gas law. Remember, the combined gas law combines pressure, volume, and temperature. So it says 200 milliliters of a gas is at 273 Kelvin and 1 atmosphere. What is the volume of the gas after it is heated to 400 Kelvin and compressed to 0.8 atmospheres? All right, so take a minute, go ahead and pause me. Go ahead and try this. Remember to use your combined gas law and give this a shot, and then we'll go over it here in a minute. All right, guys. So remember here, let's go ahead and look at our trusty little whiteboard that I've got going on here. All right, so remember for this, our equation is P1V1 over T1 equals P2V2 over T2. And remember, P stands for pressure, V for volume, and T for temperature. Now, the really nice thing was the only one we'd have to worry about changing is temperature, but our temperature was already given to us in Kelvin. So all we need to do for this problem is to plug it into our equation and solve. So let's go ahead and do that. I'm going to bring this down so I can write a little easier. But we're going to take P1, which was 1, and we're going to times it by V1, which was 200. And we're going to put that over T1, which was 273. And then we're going to make that equal P2, which is 0.8, times X, which is V2. We don't know. We're trying to solve for that. And our T2 was 400. So this is what we have when we set it up, right? All right, so now we need to solve. Now to solve for this, remember we're going to cross multiply. Okay, so this is going to be 200. So 200 times 400 is going to be 80,000. And then we're going to take, I got my calculator here, we're going to take 273 times 0.8. And we get 218.4x. All right, now to solve for x, we have to divide both sides by 218.4. So I'm going to take 80,000 divided by 218.4. Sorry, I gave me an error there. And you're going to get x equals 366.3. And what's our unit? I'm going to go look up here. Milliliters, so I put milliliters down here. And that's how we use our combined gas law. All right. So today, we are going to do our last lecture of the year. I know you guys are all really excited about that. So we are going to look at our very last gas law, which is going to be Dalton's law. So hopefully you have your notes out in front of you. Now this is a name that we've talked about before. If you remember, we talked about John Dalton back when we were doing atomic theory. He was one of the big guys who discovered the different parts of the atom. And he did that because he was studying gases. However, to be a little bit more specific, Dalton actually was studying mixtures of gases. And so what he figures out is that most gases are actually a combination of multiple gases. For example, the air we breathe. So the air we breathe is not just one gas. It's made up of multiple gases such as oxygen, nitrogen, CO2, and water vapor, and a few others. So it's a combination of a multiple number of gases. So as Dalton is studying this and he's looking at pressure, he figures out something. And what he figures out is that each gas has its own pressure within the total gas. He's going to call this partial pressure. So what he figures out is that oxygen has its own little pressure, and CO2 has its own little pressure, and water vapor has its own little pressure, and nitrogen has its own little pressure. So within air, each of these gases have their own pressure. And from this, he develops what we call Dalton's law, our last law here. Dalton's law says for a mixture of gases, the total pressure, so the total pressure of the air around us, equals the sum of the partial pressures of the gases present. So what that means is if you added up the pressure of oxygen plus the pressure of nitrogen plus the pressure of CO2 plus the pressure of water vapor, you would get the total pressure of the air. So it's just saying that the sum of the total is equal to its little parts. And we represent this by saying P total equals P1 first gas plus P2 second gas plus P3 third gas, depending on how many gases you have. So let's look at an example. So this is just simple addition, guys. So let's say that we have a gas that is made up of two gases. So we have this mixture of a gas that's made up of oxygen and water vapor. All right, let's see what we're told about them. We're told that we want to find the partial pressure of oxygen. If the water vapor pressure, so we're told water vapor pressure is 26.7, and the total pressure is 772 mmHgs. All right, so let's take a look here. We're going to use our equation, right? P total equals the partial pressure of oxygen plus the partial pressure of water. And so we just plug in. We were told the total pressure was 772. We don't know the partial pressure of oxygen, but we do know the water vapor was 26.7. So to solve for P of O2, we simply subtract 26.7 from both sides. And we will get that X equals 745.3 mmHg. Okay, that's all there is to this, okay, guys? And we'll look at practice 6.6, 1 and 2 here in a minute. All right, so your assignment, these are your last two assignments. We are going to close down our last day of instruction is May 8th. What I'm going to be doing from May 7th, Thursday, and May 8th, Friday, is I'm going to be holding live Zoom sessions during your class period. So I'm going to have you just all sign in for me on that date. That way we can just make sure that we're good with any announcements and that we just touch base. I won't keep you long, probably no more than 10 minutes, but I will ask that you come to that. And you need to make sure your assignments are turned in by their due date here. I will not be accepting assignments anymore after May 8th. We're done at that point. Please remember that May 11th on Monday is the day you will be turning in your devices and anything you have that needs to be returned to the school. All right, so your last assignment is to do your practice 6.5 and 6.6 quiz. I'm going to do your practice 6.6 here with you in just a second. Remember that you may use your notes. You may use your practices on that. Remember, it's timed. Only 5 questions. Comes from a pool of questions, so every quiz looks different. For Maroon Day, that will be due for you May 7th at 11 p.m. Gold Day, that will be due May 8th for you at 11 p.m. And then you have one more of your CK12. You guys have done 2 of these so far, so I don't think you should have any problem. You'll be reading about Dalton's Law. And then make sure, sorry, that's in my eye. Make sure you click the green View Practice button and make sure you do until you get 10 correct. Not just 10 questions, 10 correct. You can keep going until you get 10 correct. When you reach 10 correct, you get 100%. If you stop before that, you don't get the 100%. So keep doing it. And that's also the same due dates as above. All right, guys. So let's look over practice 6.6, 1 and 2. All right, so let's look at number 1. Number 1 says a mixture of oxygen and water vapor have a total pressure of 754 mmHg at 22 degrees Celsius. Now, temperature doesn't matter in this case, guys. We are totally only focused on pressure. The partial pressure of water vapor at 22 degrees Celsius is 21. What is the partial pressure of P of O2, of the oxygen gas in the mixture? All right, so here is our setup, right? We have P total, which is partial of oxygen plus partial of water vapor. We were told total was 754 and that the pressure of water was 21. So we need to find P of O2. So what do we do here? We subtract 21 from both sides, right? So what is the partial pressure of oxygen? It is simply 733 mmHg. All right, so that's number 1. Let's look at number 2. Number 2 says the total pressure of a mixture of water vapor, so P of H2O, and nitrogen, P of N2, is 97.32 kilopascals. So my total is 97.32 kilopascals. Calculate the partial pressure of the nitrogen, so we don't know what P of N2 is, if water vapor is 3.07. All right, so here's our setup. So P of total is 97.32. We know that. Water was 3.07. We don't know N2. So to solve this, we're simply going to subtract 3.07 from both sides. And we'll get that P of N2 equals 94.25 kilopascals. All right, guys, that is it. Practice 6.6 is done for you, so you just need to be working on those 2 assignments. As always, if you have any questions for me, please reach out to me. I'm here for you. Talk to you soon. Bye.